Welcome to Pachehra Talks in Well-Architected Framework series, which is a part of AC 305. We are here to explore reliability pillar into a little deeper, where we'll see what all options Azure provides to build a reliable architecture. So in this video, we are going to talk about ensuring highly available architecture and recovering from failures, because these two construct actually build the reliable architecture. So we are going to talk about these two things in little detail as per Azure platform. So if we need to talk about highly available architecture, these are some options that we can utilize. We are already aware of availability sets, availability zones, load balancing, and pass capabilities. Availability sets provide us update domain, fault domain, and gives us the redundancy in a data center. But if the entire data center goes down, AV set couldn't help us. In that scenario, we need availability zones. And these both the features can promise SLA when we are running more than one virtual machine in different AV zones or in a different update or fault domains. So we need load balancing, because if one VM is down, health probe will tell load balancer this VM cannot cater the request. Let's divert the request in a different virtual machine. And then the platform capabilities. Platform as a service, I meant. PaaS services has inbuilt highly available architecture, whether it's Azure SQL or it's app services or any other PaaS services. Most of them already has highly available capabilities, which makes your architecture, your application reliable, because ensuring highly available architecture is one of the construct that makes our application highly reliable. So once we have, right here. Once we have highly available at every point and successfully avoided the single point of failures as per the required SLA that we discussed in the previous video, then it's time to think about the second construct, which was recovering from failures. And if we talk about recovering from failures, we got two options here. One is the disaster recovery, and another one is the backups. Both has a different approach, and both has a different use cases. But yes, both builds BCDR. So disaster recovery is uh, is something which is very important when we talk about the reliable applications, because disaster can strike and hamper the highly available system, and we need to plan to get the services up and running again. That's your disaster recovery. So disaster recovery is about recovering from high impact events that result in downtime and data loss. A disaster is a single major event with an impact much larger and long lasting than an application can mitigate through the highly available portion of its design. So the question comes, how can we create a disaster recovery plan for our applications, for our environment? Or so this is something which is not a turnkey. You need to have a proper understanding of your application. There is a proper strategy that needs to be put in place, because DR or disaster recovery plan is a single document that details the procedures that are required to recover from data loss and downtime caused by disaster, and identities who is in charge of directing those procedures. Operators should be able to use the plan as a manual to restore application connectivity and recover data from disaster scenarios. If you're wondering why we need that, because the people who are actually creating the disaster recovery plan, they might not be available 24/7, or they might have left the organization. So everything should be documented step by step. So whosoever is there when alarm rings, it's a disaster situation, to follow the steps which are mentioned in the document. So creating a disaster recovery plan requires expert knowledge of the application's workflow, data, infrastructure, and the most important, dependencies. We need to think of each and every aspect of an application when we create the DR plan. A complete plan needs to specify two critical business requirements for each process implemented by the application, which are, if you're guessing RPO and RTO, then yes, you are right. RPO, the maximum duration of acceptable data loss. RPO is measured in units of time, not volume. It's like 30 minutes of data, or hour of data, or 4 hours of data, and so on. RPO is about limiting and recovering from data loss, not data theft. It's not about data theft, but recovering from data loss. If we need to talk about RTO, the maximum duration of acceptable downtime, where downtime needs to be defined by your specification. For example, if the acceptable downtime duration is 8 hours in the event of disaster, then your RTO is 8 hours. And these numbers are not uh, the hard line. Like within it, like once the 8 hours hit, your application's up and running. But you have to plan your application recovery in such a way that it should be within the 8 hours. And the process of specifying RPO and RTO is effectively the creation of disaster recovery requirements for your application. Usually, when we go and talk to the customers, these things would be decided by the customer because it's their application. If you are not involved with the customer in finding out the RPO and RTO, you are only involved in creating the disaster recovery from the infrastructure perspective, then yes, they will provide you the RPO and RTO. And how they find the RPO and RTO, it requires proper analysis, proper uh, guidance, because it requires establishing the priority of each workload and category of data and performing cost benefit analysis. And the analysis includes concerns such as implementation and maintenance cost, operational expense, process overhead, performance impact, and the impact of downtime and lost data. Much of the value of DR plan comes from the research and analysis that goes into the discovering the potential impact of a disaster and the cost of mitigating the risk. Because it's very simple. You do not want to pay more than you're earning. For example, if you go and try to create the very minimum RPO and RTO for application, that means you have to spin up those many resources, means cost. That's the reason it's a proper balance. Disaster recovery is not an automatic feature. It must be designed, built, and tested. An app that needs to support a solid disaster recovery strategy must be built from the ground up with disaster recovery in mind. And disaster recovery has two main concerns: data recovery and process recovery. Data recovery can be done using backups and replication to restore lost data. Recovering services and deploying code to recover from outages is all about process recovery. Replication duplicates stored data between multiple data store replicas, unlike backup, which creates a long lived read only snapshot of data for use in recovery. Replication creates real time or near real time copies of live data. Azure provides its own backup services, which could be further replicated as GRS. Azure also provides replication options in most of the past services like storage and SQL, Cosmos, and of course, ASR for the VMs, and many more. Now, this is something very important. Neither replication nor backup are complete DR solutions on their own. Data recovery is only one component of disaster recovery, and replication will not fully satisfy many kinds of disaster recovery scenarios. Check this out. In a data corruption scenario, the nature of the corruption may allow it to spread from the primary data store to the replicas or secondary, rendering all the replicas useless and requiring a backup for recovery. Very important. Now, if we talk about process recovery, after a disaster, a business data isn't the only asset that needs recovery. Disaster scenarios will also commonly result in downtime, whether it's due to network connectivity problems, data center outages, DNS, or damaged VM instances, or anything like that. The design of your application needs to allow you to restore it to a working state. So it's not only about data, but also about process. In most cases, process restoration involves failover to a separate working deployment. Depending on the scenario, geographic location may be a critical aspect. For example, a large scale natural disaster that brings an entire Azure region offline will necessitate restoring services in another region. Your application's DR requirements, especially RTO, should drive your design and help you decide how many replicated environments you should have, where they should be located, and whether they should be maintained in a ready to run state or should be ready to accept a deployment in the event of disaster. So that's how you come up with the disaster recovery planning. There's too many things involved, but we are not covering that aspect right here. We are covering the reliability, and disaster recovery and backups are the two important pillars for that. And let's talk about backup a little more. Backup is the final and most powerful line of defense against permanent data loss, as we already seen the example of replicating of corrupted data. To establish backup requirements for applications, we need to think of certain aspects like how much of this type of data can afford to be lost, measured in duration. If you are thinking what I'm thinking, RTO or RPO, then it is most relevant to those terms for sure. The maximum amount of time a restore of this type of data should require, backup retention requirements, how long and at what frequency do backup needs to remain available. These concepts, uh, duration of acceptable loss, will generally translate directly to RPO, and maximum amount of time is RTO. Both requirements should be developed relative to the cost of achieving them. Every organization would like to say that they truly can't afford to lose any data, but often That's not the case when the cost of achieving that requirement is considered. And it's your job to explain this to your customer and come up with the best possible strategy, a balanced one with compared to cost, RPO, and RTO. Backup absolutely plays a role in DR, but backups, restores, and their associated scenarios extend beyond the scope of DR, as we have already talked about. Backups may need to be restored in non disaster situations. That's new. We didn't talk about this before, including those where RTO and RPO aren't of a great concern. For example, if a small amount of data older than your backup interval is corrupt or deleted, but the application doesn't experience downtime, your app may never be in danger of missing its SLA, and a successful restore will result in no data loss. So, if you think about to summarize this, if you think about disaster recovery, it is more like a high scale event, and backups can help you with small corrupted or deleted data. And in that scenario, there is something you need not to restore the entire VM. You can simply go ahead and restore that particular disk and the file that you need. And one of the most important thing is you should never get confused between archival, replication, and backups, because archival is the storage of data for long-term preservation and read access. Replication is the near real-time copying of data between replicas to support high availability and certain disaster recovery scenarios, because that's what we do when we create the disaster recovery plan. We replicate into a different region or a different zone. Some requirements, such as data retention laws, may influence our strategies for all three of these concerns. Archival, replication, and backup all require separate analysis and implementation. And if we talk about Azure backup and restore capabilities, well, Azure offers several backup related services and features for various scenarios, including data in Azure as well as on premises data. So let's go and check Azure Backup. Azure Backup is a family of backup products that back up data to recovery services world for storage and recovery. Azure Backup serve as a general purpose backup solution for cloud and on-premises workflows that run on VMs or physical servers. It's designed to be a drop-in replacement for traditional backup solutions that stores data in Azure instead of archive tapes or other local physical media. There are 4 different products and services can use Azure Backup to create backups. Very first is Azure Backup Agent. Then we have System Sender Data Protection Manager. We have Azure Backup Server and Azure IaaS VM Backups. And of course, just like in HA, we had PaaS capabilities in PaaS services. We do have inbuilt backup capabilities in PaaS services that we can utilize to back it up. So if we talk about Backup Agent, it's a small Windows application that backs up files, folders, and system state from the Windows VM or server on which it's installed. It works in a way that's similar to many consumer cloud-based backup solution, but requires configuration of an Recovery Vault or Azure Recovery Vault. Once you download and install it onto a Windows Server or VM, you can configure it to create backups. And this is very important. With Azure Backup Agent, we can run backup thrice a day, 3 times a day. System Center Data Protection Manager is a robust, fully featured enterprise-level backup and recovery system. DPM, we also call it DPM. DPM is a Windows Server application that can back up file systems and virtual machines, including Linux, create bare metal backups of physical servers, and perform application-aware backup of many Microsoft Server products such as SQL Server and Exchange. And DPM is a part of System Center family of products and is licensed and sold with System Center. And then we have Azure Backup Server. It is just like a brother of DPM, but it's licensed as a part of Azure subscription and doesn't require a system center license, but usually does all the things that DPM does. If we talk about ISVM backup, it's a turnkey backup. Just select the VM, enable the backup, and restore feature of Azure virtual machines. VM backup supports once per day backups for Windows and Linux virtual machine. This is something you need to keep in your mind whenever you design the backup policies for your customer. It supports recovery of individual files, full disk, and entire VMs, and can also perform application consistent backups. Azure Backup can add value and contribute to the backup and restore strategy for IaaS and on-premise application of virtually any size and shape. And with past capabilities, like we do have inbuilt backup in Azure SQL and app services, even the storage account, we can restore, we can back up the blob with the help of Azure Backup now. We That's all are the capabilities that we have in Azure, that Azure provides to make our application reliable. So yes, with this, we are done with this reliability pillar. There is a lot more if you would like to go pretty deep, but we have covered uh, a lot. So let's meet in another video and try to cover another well architected frameworks element. Till then, take care. Bye bye.